Hello everyone, we will solve this today's LeetCode problem. This is a LeetCode medium one. So let's see what it is. So we have question get equals substrings within budget, right? So here we have given two strings s and t of the same length and integer max cost. You want to change s to t, changing the ith character of s to ith character of t cost si minus ti, the absolute difference between sky value of the characters. Okay, return the maximum length of a substring of s that can be changed to be the same as corresponding substring of t with cost less than or equal to max cost. If there is no substring from s that can be changed to its corresponding substring from t, return 0. Okay. So we have given a two string s and t of the same length and integer max cost. So here what we need to do, we need to find the max cost. We need to find the max length of substring from s which can be equals to substring of t, right? That's we need to find. And for that we can do operation. What is operation that change we can change any ith character of s to the ith character of c. We can change any ith character of s to t, right? Any ith character of s to ith character of t, which will cost us which will cost us absolute value of si minus ti, right? This will cost us, right? So and how much we can till how much cost we can change this. We have given a limit, that is a max cost, right? We have given a max cost, that is given a limit for that. At till this limit, this till 3 or less than 3, we can change ith character to t character, and simply we can find how many maximum length of substring which has equals to substrings of t, right? So if we see the first example here a b c d and b c d f and max cost 3. If you see here, if I try to change a to b, because this is not same, so what will the absolute value of a minus b? That would be 1 for 0th. That the cost would be, this is the index, and this is the cost, and this is the cost. So what would it would be? It would be 1, of course, right? Again for 1th, it would be 1, same. For 2, again it would be 1, right? And for d, what would be, which is 3, it would be 2, right? DEF, right? So 2 will cost. So if you see, we have total max cost is 3. It means we can't change all the ith character to ith character to uh, change ith character of s to ith character of t, right? So which one would you choose? So if you see here max cost 3, it means you will definitely not choose first to this 2, because here 1 1 1 is 3 here. So if you choose 1, you can change 3 characters. But if you choose third, which cost us 2, it will only can change 2 characters. So we will choose this 0 1 and 2 and make this bcd. This changes to bcd. So our length, so the answer will be 3, right? So the answer would be 3, right? So again for the same a b c d and c d f, if we choose here, if you see, for changing the ith character to anyone, the first is 2, again second is 2, third is 2, and def, which is again 2, and max cost is given is 3 only. So we can only change one character, because if I want to choose another character, that will cost us 4, which is greater than the maximum cost which is given. So answer would be, in this case, would be 1 only, right? Okay. So we have understood that we can't we can't go beyond this limit max cost. So how we will solve this? So the main problem, the one thing which the main problem which I see here, the problem which I see here is that how will we determine that character which ith character should we choose, should we choose. Okay. So if you see constants here, length as dot length is 10 to the power 5 and max cost is 10 to the power 6. It means we can't use simply a brute force approach, which would be n into max cost. That would be huge, right? So we need to try anything else which would cost only O of n, right? So we can only think of any approach which cost us of which should we have time complexity of O of n or O of n log n, right? Okay. So how we choose any specific characters in this, right? Something is that. So if I try to choose, so the first thing which can comes in your mind is that I will choose all the substrings which has same which has the common substrings between S and T and C its left and right position. But how will you choose which side of it need to be changed and which will give us the max cost within limit, right? So that's not a predetermined code, right? And we can't use here overlapping because that will give us n into m cost because max cost will change and also change, so that will also not work. So the one thing, if you see here in this, suppose I choose any example, a d b c, right? And here I choose what I choose b, or okay, c d, uh, f, b, again f. Okay, if I choose this in right, if I choose this, what if you see here some pattern would be there. What pattern? See, if I try to change a to c, what it would be? It would be 2. If I try to change d to d, it would be cost as 0, right? If I try to change e to f, what it cost? 1. What it cost? Would give us 1. If we try to change b to b, it would cost us 0. And if I try to change c to f, it would cost us 3, right? D F, of course, 3, right? So if you see here 20103, and we have given a max cost anything, suppose uh, 3 is given. Okay, suppose 3 is given. So if you see in this array, this question transforms to this. Now what you need to find here, you need to find the maximum substring length which gives us the cost less than equals to 3. Don't you think this question transforms to the max length of substring not subarrays, the max length of subarrays, which the max length of subarrays whose summation is less than or equals to k. Don't you think this question transforms to this max length of subarrays whose summation is less than or equals to k, right? So what we do in these questions, if you have solved this question, max length of subarray summation is less than equals to k, you got a hit of a simple approach. What would be? Let's see. For this three suppose I try to 2 0 then 1. This 2 is less than 3, we can take this 0 is less than 3, we can take this 1 is less than 2 plus 1 is 3, which is less than equals to 3, we can take this, right? We can take this. So it means if I start from 0th position, so I can, and 0th position and some value would be 0, so I can take 0th, so some will be 2, then I can take also 1, then some will be 0, I can take 2, some would plus 1. Now can I take fourth, third index? Yes, I can take, it would be 0. But can I take this last index, fourth? No, I can't take this. Why? Because it would give us 6, which is greater than the max cost, which is not affordable. Then what we need to do? So how many length would it be less than 3? This length 0 1 2 3, which is, so answer would be, to answer can be a possible answer of 3, right? So but here 6 is greater than, so I can't take this 3 now. So what I will do, I will maintain a 2 pointer, or you can take a sliding window. So it means this j at 0, I what I will do, I will start decreasing, I will start subtracting from the first position. This becomes 6 now. When I go to from starting position, this zeroth would be minus from here, right? This zeroth would be minus from here, which is 2. Now it becomes 4, and my j becomes 1. It would become 1 here, jth at here. This 0 is also, but is this 4 is already greater than max cost, so it is still greater than. So what we'll do, we will again increment this, so it will become 2 now. Now this, if I minus this, it becomes 3. If I minus this 4, it becomes 4 minus 1, which is equals to 3, which is less than equals to max cost, right? So it means at j is equals to 2, and from this 2 to this is a valid substrings which can cost us 3. So from j to this, from j to 103 to this, so answer would be what? I minus j plus 1. I is at 4, j is at 2, so 4 minus 2 plus 1, which is 3. So total length is 3. So answer is before the answer is 3, and again the possible value is 3. So what would we take? We will take the max of both. We will take the max of both, which is again 3. So if you see here, what we have changes, we have changes this string question to the question which we have already solved. This question is a very basic question of sliding window. You must have solved this question. If you haven't, please solve this question first and then comes to this question, right? Please solve this question first, right? So max length of subarrays of summation less than k, and this now becomes a sliding window approach. This has now become a sliding window approach. This question now becomes a question of sliding window, sliding window, right? Sliding window, right? So what we do, we will so what we'll do, so we have given strings now, not this 20103, right? So we will deal with strings, not deal with this summation. So what we will do, we will uh, we will take same example here. We will take same example here, and the same summation, the same I value initialize with j value, and the same value, and the answer would be here, right? Which is nice with 0. So this a to c, the cost is, the cost is 2, right? The max cost I would take here is 3 again, right? So it will cost us 2, which is less than 3, so we can take this. So I will increment this I, right? So this I becomes not now at position this. Now this d and d, absolute difference is 0, right? Because it is same. So we can take this. Now I becomes 2, ith index goes to 2. E and f will give us 1, which is again less than equals to 3. So ith index would again move forward. It becomes b. So b minus b is 0. So we can again take it. So ith index would be at 4. The same thing. Instead of storing 20103, what I am doing, I am checking a minus c in the same process which we are doing for 20103, right? Because this 20103 is comes how comes is this. So it comes from absolute difference between this ith character to this character. So the same things happening here, right? So the same thing we do from here, right? So the sliding window approach we follow, we will use the sliding window approach. We will use the sliding window approach. So what we do here in the sliding approach here, we use 2 pointers, and we we sum the we start summation. We start taking summation of cost till we we are not we are not go we are not go out of the limit of max cost. And if we go, then we will start decreasing our window. What does it mean? We will start we will start subtracting from starting part, uh, from starting, that is start from zero, zeroth index, right? Till where? I till I comes within limit of max cost, within limit of max cost, max cost, right? And we will whenever we are in limit of within limit of within limit of max cost, what would we do? We will store the max length, we will store the max length, which which will be, which is which we have got, which we have got in our windows, right? And that would be the max of all answer would be, and max of all answer would be our answer, right? So this is we do, right? So let's try to implement this, you will be better understand it, right? So it's just a simple sliding window approach. You That's a simple sliding window approach. Let's see, it's a simple sliding window approach. So let's start with, okay, so first I need to define the ith index, jth index, which will start from 0, and the answer, the summation, and the answer, right? Okay, so we will start from I is equals to 0 to n. Now what I will do, I will just submit it, take summation of difference between the si character minus ti. So if the same characters goes, it will give a 0, otherwise it will give me some values, and that will store in my summation. And what I need to choose, I will need to check that this summation should be, should not go out of the max cost. So I need to check that this sum should, if this sum is greater than max cost, what I will do, I will start iterating from the first, from the left part, that is starting point, and it, decrease it. So how will I do that? This jth pointer, I will use this another pointer for doing this. So I will minus this the sum with my jth and tj, right? And till where I will increase this and decrement this. So the jth will be never be greater than this ith characters, right? So first limit is that the jth can be equals to only till ith, right? It should not be greater than ith. The second condition is the sum, till the sum is not less than equals to max cost, till then I will decrease it, right? And what I will store, I will simply store the max answer I minus j plus 1. That would be our substring, that would be our length of substring, which is equal, of course, right? Why I'm not checking that j sum is less than max cost? Because I'm definitely sure either j is greater than I, or sum is less than equals to max cost, then only this while loop will be stopped, right? So if j is greater than I, so I minus j plus 1 would give us 0. And when sum is less than max cost, then this would give me some length, right? So here this answer will restore our max length, and we will simply return our answer from here. So this is how we will solve this question. I hope I have not done any mistake in implementation part. Let's try to run this. Yeah, we have passed the sample case without any compilation error. Let's submit it. Yeah, we have successfully passed all the cases. So what are the time and the space complexity of this approach? So that's simple. That's, you can see by yourself that it is O of n only, because this j is less than ith would give us at most O of n, right? So O of n, and this would give us O of n, maximum part is O of n, not uh, greater than O of n, right? So That would be O of n plus O of n. That would give us O of, ultimately O of n, right? Uh, and what are the variables we have taken? We have not taken any extra spaces, so that is O of 1. So the space complexity would be O of 1, because we have not taken any extra spaces, right? So if you understand this, how will this is O of n? Because this jth pointer is moving only one time. If you see, the jth pointer is moving only one times from 0 to n. It is not moving every time. It is moving only one time from 0 to n, right? If you see here, this is moving in one time and this is moving one time. So the both can maximum goes to O of n to O of n. That would give us O of n, right? So this is how we will solve this question. So yeah, thank you, hope you understand it. Bye bye.